The next step of our process is going to be to take our circuit and make a virtual version that can eventually be translated into a PCB. I've got Fritzing open, and in this piece of software you can do some circuit building in a virtual context, and then also translate into a schematic view, and then ultimately a PCB. And this is what we're aiming for, but we will begin with the breadboard view. This is a little bit different than what we've done in Tinkercad, but not so different. For each component, we can add parts from the upper right corner of the program, and there are core parts, which are going to include a lot of the common ones that we're going to be interested in. But if there's something that you can't seem to find in here, you can look under the search. This is probably the next easiest place to look. So for instance, I've got my speaker. I found the potentiometer that fits on the breadboard. Although this one doesn't seem to want to plug into the breadboard well, but the spacing is correct. It is important that we have the correct footprint. So there may be some capacitors that are much smaller than this. And if you see that the lead spacing is different than a breadboard, we probably want to go back and try to find another component. Okay, so what I have so far is I have the speaker, the potentiometer, 2 capacitors, we'll have an LED, and then we're going to have a couple different resistors. So I can copy and paste these resistors, and we can set the values after the fact. But the one component, I think there's only one that we're missing right now, which is the 555 timer. Oh, we are also missing the power supply, right? So if I look under battery, I may choose to use, I had a 9-volt that I used before. Maybe not that one though. Yes, this one. So I'll use this 9-volt. We can't actually simulate it here. So in some senses, it doesn't really matter. If the spacing is right and it's going to have the correct footprint and we know what it represents, the rest doesn't actually necessarily matter. We may get some better labels, but our printed circuit board isn't going to have any silkscreen on it. So we can get away with maybe some substitutions as long as the spacing is right and we know what it represents. The last one that we're missing is the 555 timer. So if I search 555, we'll also see that there's quite a few. This one has the normal lead spacing that would go across the bridge, and so that's good. I'll just talk very briefly through a few things about construction here, and then we'll zip this circuit together in no time. If you have a component that you want to rotate, we can use the square brackets to rotate an object quickly, or you can use the rotate, and then some of these objects you can use flip with as well. So if I rotate this twice, I can plug it into the breadboard there. And with this potentiometer, I'm not sure actually what it is about this design that it doesn't sit on the grid in the same way that the breadboard does. So I'm going to instead just connect it with some wires. One of the first connections from our circuit diagram is to run a 1K resistor to one of these leads on the potentiometer. And so if I were going to do that, I might take one of my resistors, I'll flip it, and I'm just going to place this in a row because we're actually going to share this power to a couple locations. And I want to change the resistance. Now with any component selected in the bottom right corner, we'll have some of its properties. And if there's a rating on the component, like capacitance or resistance, this is where you're going to be able to modify it. So I would look down for resistance, and I can go through this long list of all the common default or all the common values that you would expect to see. I can choose 1K, and it's going to be reflected in the color codes there. If I want to make a wire connection, I can make a wire connection onto any of the breadboard pins. I can also make connections, wire connections to my cursor changes to a different connection or to a different icon if I'm over top of something that can have a wire dragged out from it. So if I were to drag a wire and connect it to the breadboard, let's say here for instance, if I move my component around, I can see that I've made a connection between those two spots. Now we do want to keep our circuits clean when we can, so you can click to add or double click to add an elbow. And this is going, if you move this elbow, you can just click and drag on it and you will be able to introduce a bend at a certain angle. If you hold control, you're not going to be locked to the grid anymore. So sometimes that may be useful. I should say that was control after, oh no, that's holding control before I grabbed the point. If I hold Control and create a new anchor, it will be a curved anchor. So it is possible to do curved lines in Fritzing, but the default, and then once you start curving a line, it will like be a curvy line after that. So depending on what you want to do with your circuit wiring, that may come in handy. For our purposes, again, we're not simulating from the breadboard, but as we make these connections on the breadboard, you'll see that the connections are going to start to show up in the schematic view, and we'll also get air wire connections in the PCB view, which are showing us that we've got we have to create some connections here. Okay, and we'll do this in a separate video, but that's sort of the basics of putting things together, right? Most of our components should be able to live directly on the breadboard, and you can get some information about what some different pins are. If you mouse over the pins on the 555, for instance, it gives us both the number and the name of each of those pins. So we have 1, 2, 3, 4 on the bottom, and we have 8, 7, 6, 5 on the top. Now I'm going to put this into fast forward mode. Actually, before I do this very quickly, the one thing I didn't show was how to change wire color. So most different features, you can select and right click, and you can change something about the draw order if they overlap, and you also can get to wire color this way. So particularly if we're supplying, power to something, it may be worthwhile to color it red, and if we're going to ground with something, it may be worthwhile to color it to black. And then beyond that, we just want to think about making good clarity, right? So if we've got a bunch of wires that are close to each other, giving them different colors just will make it a little bit easier to read. All right, so after some work here, I think I've got a good breadboard circuit done. And so we'll stop this video here, and in the next step, we'll see how we can take this, move into the PCB view, and create our printed circuit board pattern.